Hi everyone, Assalamualaikum. In this video, we are going to continue with Series 3, a virtual workshop for final exam preparation, Calculus 2 for Engineers MAT235. Hope you enjoy this video. Now we go to another segment, which is sample of final exam paper, right? Right, from this sample of final exam papers, we have 3 printed pages, okay? And then we have 5 major questions. Question 1, 2, 3, 4, and 5, okay? And the total marks equals to 100 marks. And the percentage equals to 60%, okay? And then all these questions you need to answer within 3 hours time, okay? And another 30 minutes you use to scan and upload your answer, right? Next, we look at the sample of solution. We look at question 3A. Question 3A. Given fxy equals to y squared plus 1 over x plus 1. Use total differentials to estimate the value of f 3.98, 3.085, 5 marks, right? To solve this question, step 1, we need to identify x, x naught, y, y naught, and dx, dy, right? X means the first value, okay, the given decimal value, okay, which is 3.98, okay. X naught means the nearest whole number, okay, from this decimal value, okay. So our X naught equals to 4, right? And then we need to find dx. Dx equals to x minus x naught, okay, which is equals to 3.98 minus 4, and it is equals to negative 0.02, right? Y equals to the second decimal value, okay, which is 3.085, right? And then we need to find y naught, okay? Y naught equals to the nearest whole number from y, okay? So we have 3, right? After that, we need to find dy, okay? Dy equals to y minus y naught, okay? Which is equals to 3.085 minus 3, okay? So we have dy equals to positive 0.085, right? Next, we continue with step 2. Identify the function fxy and the value of fx naught, y naught, okay? We are given fxy equals to y squared plus 1 over x plus 1, okay? So, to find the value of fx naught, y naught, okay, we can write equals to f, okay, we replace x naught equals to 4 and y naught equals to 3, okay, then we substitute into this function, okay, so we have y squared from here, so y now equals to 3, so 3 squared plus 1 over 4 plus 1, okay. And then we simplify, so we have fx naught, y naught equals to 10 over 5 and it is equals to 2. Alright, so this is our fx naught, y naught, right? After that, we continue with step 3. Find fx and fy and its value at x naught, y naught, okay? from fxy equals to y squared plus 1 over x plus 1. Okay. From here, we need to find fx and fy. Okay. To find fx, we need to differentiate f with respect to x. Means that we treat y as a constant. Okay. So, when we treat y as a constant, we can write f equals to constant squared plus 1. So, it still equals to constant. Okay, so we have numerator with constant and then over x plus 1, right? From here, we can differentiate using quotient rule. But since we have numerator with constant only, no variable, so we can also differentiate using generalized power rule. But before that, we need to change into the form of C times, we move x plus 1 to numerator here. So we can write times bracket x plus 1 to the power of negative 1 using the properties of indices. Right? When we have multiplying by constant, okay, and we have bracket to the power of any constant, we can differentiate using generalized power rule. Okay, so when we differentiate f with respect to x, so the symbol become fx. Okay, equals to, using generalized power rule, we multiply negative 1 and the constant in front here. So we have negative c, and then we copy the function in bracket, which is x plus 1 to the power of negative 1 minus 1, okay, which is equals to negative 2. Okay, and then times, don't forget to differentiate the function in bracket. Okay, so we differentiate x, we have 1, and then plus, differentiate 1 equals to 0. Okay, and then we can write fx equals to negative. We replace c equals to y squared plus 1 bracket, and then times x plus 1 bracket to the power of negative 2 times 1. Okay, no need to write times 1, okay, because it doesn't change the original function. Alright? And we can write fx equals to negative bracket y squared plus 1 over bracket x plus 1 squared. Okay, we move down using the properties of indices. So we have to the power of positive 2, okay, or squared. Okay, so this is our fx. Okay, we differentiate f with respect to x. So we treat y as a constant, right? Right, next, to find fy, we need to differentiate f with respect to y. At the same time, we treat x as a constant, right? When we treat x as a constant, so we can write f equals to y squared plus 1 over x, we treat as a constant, so this is constant plus 1 equals to constant, right? And then from here, we can differentiate using quotient rule. But since we have numerator with constant only, okay, no variable, so we can split this fraction, okay? Or we can write f equals to 1 over c times y squared plus 1, right? And then we can expand. Okay, so we have f equals to 1 over c y squared plus 1 over c. Okay, from here we just differentiate one by one. Okay, we differentiate f with respect to y, so it is equals to 1 over c. We still have constant 1 over c in front, and then we differentiate y squared with respect to y equals to 2y. And then plus, differentiate constant equals to 0, right? After that, we can write Fy equals to 2y over C. Okay, and we replace C equals to, from here, C equals to x plus 1. Right? This is Fy. Okay, we differentiate F with respect to y, and at the same time, we treat x as a constant. Right? From the previous slide, under step 3, we get fx equals to this function and fy equals to this function. Alright? Next, we need to find the value of fx and fy at x naught, y naught. Okay? So at x naught, y naught, okay, x naught equals to 4 and y naught equals to 3 from step 1. Okay? What is x naught? Okay, x naught means the nearest whole number for x, okay, which is 4, okay, and y naught means the nearest whole number for y, which is 3, okay. So at this value, after we substitute into fx equals to negative bracket y squared plus 1 over bracket x plus 1 squared, okay, we have negative, and then we replace 3 into variable y here, and we replace 4 into variable x here. Okay, so from here, after we simplify, we have negative 9 plus 1 equals to 10, and then over 5 squared equals to 25. And then after we simplify, we have negative 2 over 5. Right, this is our fx at x naught, y naught. Right. Next, we need to find the value of fy at x naught, y naught. Okay. From fy equals to 2y over x plus 1, we replace 3 into variable y, and we replace 4 into variable x. Okay. And after we simplify, so we get fy equals to 2 times 3 equals to 6 over 4 plus 1 equals to 5. Right? So this is our fx and fy at x naught, y naught. Right? After that, we continue with step 4. Use df equals to fx dx plus fy dy. Okay, so we get df equals to, we replace fx equals to negative 2 over 5 times dx. Okay, from step 1, we get dx equals to negative 0.02, and then plus fy equals to 6 over 5, and then dy in step 1, we get 0.085. Alright? And then after we solve this, so we get df equals to 0.11. Alright? Then we continue with step 5. Estimate or approximate. Okay? We want to find the value of f 3.98, 3.085. Okay, it is estimate to, okay, we use this formula f x naught, y naught plus df. Okay, so it is estimate to, we replace fx naught, y naught equals to 2. Okay, from step 2. Okay, we get this value from step 2. Okay, and then plus df. Okay, df we get from step 4. Okay, so we have 2 plus 0.11. Okay, then after we solve this, so we have f 3.98, 3.085 is approximate to 2.11. Okay, correct to 2 decimal places. Alright. we can check this final answer, either correct or wrong. Okay, we just substitute 3.085 into variable y here. Okay, and then plus 1 over, we replace x by 3.98. Okay, and then plus 1. Okay, so from here, after we solve, so we get 2.11189. Okay, so from here, since we just approximate, okay, using differential, so this is considered correct. Okay, got it? This is the complete solution from step 1 to step 5. Okay, until we get the final answer 2.11. Right? Next, we continue with question 3b. Question 3b. Determine all the critical points of the function fxy equals to 4x squared minus 2x cubed plus 3y squared plus 6y plus 10 and the nature of each point, 8 marks. Right? To solve this question, step 1, we need to find the first and the second partial derivatives. Okay? First partial derivatives means we need to find fx and fy. Alright, first we need to find fx. Okay, we refer from this fx, y. Okay, so from here, to find fx, let's say we rewrite like this. Okay, the term containing variable x, we use green color because we treat x as a variable. Okay, and at the same time, we treat y as a constant. Okay, constant squared equals to constant times 3 still equals to constant. So let's say we put C1, okay, for constant 1. Okay, and 6y here, okay, y we treat as a constant, constant times 6 still equals to constant. So let's say we put C2, okay, for constant 2. Right? So from here, we can find fx. Okay? Remember, now we treat x as a variable. Okay? So we differentiate 4x squared, we have 8x. And then minus, differentiate 2x cubed equals to 6x squared. Differentiate any constant equals to 0. Okay? Same goes to C2 here. Okay? When we differentiate constant 2, it is also equals to 0. And when we differentiate 10, 10 also is a constant. So it is equals to 0 as well. Right? And then from here, we can write fx equals to 8x minus 6x squared. Right? Now we want to find fy. Okay? From fx, y here, okay? To find fy, we treat x as a constant. Okay? So we can rewrite term containing x in terms of constant 1 and constant 2. Okay? Because constant times 2 equals to constant, constant times 4 still equals to constant. And to find fy, we treat y as a variable. Okay? So let's say we use green color for the term containing variable y. Okay? So from here, we find fy. Okay? Alright, when we differentiate constant, it is equals to 0. Okay? And when we differentiate 3y squared with respect to y, so we have 6y. Okay, differentiate 6y with respect to y equals to 6. And differentiate constant 10, it is equals to 0. Right? Then, after we simplify, we have fy equals to 6y plus 6. Right? So this is our fx and this is our fy. Yeah, this is called first partial derivatives, right? After that, we find the second partial derivatives. Okay, so from fx here, okay, when we differentiate with respect to x, so we have fxx. Fxx means we differentiate fx with respect to x. Means that we treat x as a variable and at the same time we treat y as a constant. Okay, but from here there is no y. Okay, so we differentiate at x with respect to x equals to 8, and then minus differentiate 6x squared with respect to x, we have 12x, right? Next, we want to find fxy. Fxy means we differentiate fx with respect to y. Means that we treat y as a variable. And at the same time, we treat x as a constant. Okay? Since now we treat x as a constant, so means that all of this term equals to constant. Okay? So when we differentiate constant, it is equals to 0. Right? Next, from fy, we can find fyx and fyy. Okay? When we find fyx, means that we differentiate fy with respect to x. So, we treat x as a variable and at the same time, we treat y as a constant. Okay, since now we treat y as a constant, so from here we have constant plus constant. Okay, so when we differentiate any constant, the answer equals to 0. Right? Right, finally, we need to find fyy. Okay, fyy means we differentiate fy with respect to y. Means that we treat y as a variable. Okay, and at the same time, we treat x as a constant. Okay, but from here, there is no x. Okay, so we just differentiate 6y here. Okay, with respect to y equals to 6. And we differentiate constant 6 equals to 0. No need to write plus 0. Right? Note, okay, fxy here means partial derivative of fx. Okay, we treat y as a variable and at the same time we treat x as a constant, right? While fyx means partial derivatives of fy. We treat x as a variable and at the same time we treat y as a constant. Okay, that's why we get 0 here because we differentiate constant. Okay, but their values are equal, right? fxy equals to fyx. Okay, so to check whether your answer is correct or wrong, we can check whether fxy equals to fyx. If the value of fxy equals to fyx means the answer is correct. Right? Got it? After we find the first and the second partial derivatives, then we continue with step 2. Find the critical points when fx equals to 0 and fy equals to 0. Right? So when fx equals to 0, this is our fx. Okay? So we equate 8x minus 6x squared equals to 0. Then we solve for x. Yeah? From here, we can simplify this. So we have 4x minus 3x squared equals to 0. We dividing both sides by 2. So we get this, right? Then we can factorize x. Okay, so in bracket, we have 4 minus 3x. So that when we expand, we will get back this function, right? Then we equate x equals to 0 and the other factor 4 minus 3x equals to 0. So our x equals to 0 and x equals to positive 4 over 3, right? This is the value of x when we equate fx equals to 0, right? Next, when fy equals to 0, okay? So we replace fy equals to 6y plus 6, and then it is equals to 0, okay? We dividing both sides by 6, so we have y plus 1 equals to 0, so y equals to negative 1, okay? Then we can write the critical points are, okay, we pass 0 and negative 1. Okay, 0 is the value of x, negative 1 is the value of coordinate y, and we pass 4 over 3 and negative 1. Okay, 4 over 3 the value of x and negative 1 the value of coordinate y. Okay, so these are the critical points. Okay, coordinate 0, negative 1 and coordinate 4 over 3, negative 1. Right? Got it? After we find all the critical points, okay, then we need to state the nature of each point. Okay, so we continue with step 3. Find d equals to fxx times fyy minus fxy bracket squared. Okay, so from the previous slide, okay, we get fxx equals to 8 minus 12x. So we replace here. Okay, and from fyy equals to 6, okay, we refer the previous slide. Okay, so we replace 6 into fyy here, and then minus fxy equals to 0, okay, from the previous slide, right? So we have d equals to 48 minus 72x after we simplify, right? After we find the function for d, okay, so step 4, table of sign for d and fxx. Table of sign means we want to identify the sign for d and the sign for fxx, okay? We use this table with 4 columns. Okay, column 1 for critical points. Okay, column 2 for sign of d. Okay, our d equals to 48 minus 72x. Okay, column 3 for sign of fxx. Okay, our fxx equals to 8 minus 12x. Okay, and the last column for conclusion, right? We have two critical points, which is 0, negative 1, and 4 over 3, negative 1. 0 and 4 over 3 are the values of x, and negative 1 is the value of y, right? Alright, to find the sign for d, we substitute 0 into variable x here. Okay, so after we simplify this, we get positive sign. Alright, we just put the sign only. Okay, and then to find the sign for fxx, okay, since we have variable x here, no variable y, so we just substitute variable x into here. Okay, and after we simplify, we get positive sign. Right? Alright, next, for critical point 4 over 3, negative 1, to find the sign for d, since we only have variable x here, no variable y, so we just substitute x equals to 4 over 3 into variable x here. So after we simplify this, we have negative sign, right? Alright, and then to find the sign for f as x, okay, since we only have whatever x here, no whatever y, so we just substitute x equals to 4 over 3 into whatever x here. And after we simplify this, so we have negative sign, okay? No need to put the value because we just consider the sign, alright? After that, we can conclude the nature of each point, right? So how to conclude the nature of each point, right? From here, if we have D, from here, D equals to positive sign, okay, here. And after that, we have f as x, positive sign. So means that we have minimum point, right? I repeat, if we have D positive, okay, D positive, f as x also positive, so means that we have minimum point, right? If we have D equals to negative sign, okay, here, means we have saddle point, right? If we have D equals to negative sign, so no need to consider f as x. We just consider D equals to negative sign. So it is saddle point, right? So we can write minimum point is 0, negative 1. And saddle point is coordinate 4 over 3, negative 1. Right? Got it? So these are the nature of each critical points. Okay? These are the complete solution for question 3b. Okay? From the previous slide, we get minimum point equals to coordinate 0, negative 1, and saddle point equals to coordinate 4 over 3, negative 1. Right? We have 4 steps. Step 1, find the first and second partial derivatives. Step 2, find the critical points when fx equals to 0 and fy equals to 0. Then we will have critical points. After that, we find the function for D using this formula. And then step 4, we use table of sign for D and f as x. Okay, we just consider the sign only, right? Next, we continue with question 3c. Question 3a. Find an equation of the tangent line to the curve x squared plus xy minus y squared plus 7x minus 3y equals to 26 at the point 3, negative 2, 6 mark. Okay. To solve this question, we refer this, okay, from the function fxy. Slope or gradient is given by dy over dx equals to negative fx over fy. Okay, so from here we need to find f first. Okay, what is f? Okay, f means we bring all the term to left hand side so that right hand side equals to 0. Okay, so after we bring all the term to left hand side, okay, so we have x squared plus xy minus y squared plus 7x minus 3y. And when we move positive 26 to left hand side, so we get minus 26. Okay, and we assume equals to f. Alright, so from f here, we need to find fx using partial derivative. Alright, so to find fx, first we can rewrite f like this. Okay, when we find fx, means we treat x as a variable, and at the same time, we treat y as a constant. Right? Let's say we use green color for variable x, and we use red color for constant y. Right? And from here, we can find fx. Okay, fx means partial derivative of f. Okay. Alright, and then from here, we also can write like this. Okay. To find fy, okay, we need to treat x as a constant, okay, and y as a variable. Okay. Let's say we use y in green color, okay, and let's say x red color, okay, for constant. Okay. So from f here, okay, we can find fx. Okay. For the green color, we need to differentiate, okay, because we treat x as a variable. Okay. When we differentiate x squared with respect to x, it is equals to 2x. Okay. And then, since y now we treat as a constant, so we just put y here. Okay. You just imagine, let's say you want to differentiate 2x. Okay. 2 is a constant. Okay. What is the answer if we differentiate to x? The answer equals to 2, right? Okay, why 2? Because we just put 2 and then we differentiate x equals to 1. Okay, you imagine when you want to differentiate constant y and variable x, let's say you use 2x. Okay, when you differentiate to x, the answer equals to 2 times 1. So, when you differentiate constant y x, so you just put constant y in front and then differentiate variable x equals to 1. Okay, and then minus differentiate constant y. Okay, constant squared still equals to constant. Differentiate constant equals to 0. Okay, and then when we differentiate 7x, the answer equals to 7. Why 7? Because we just put back constant 7 and then we differentiate variable x with respect to x equals to 1. Alright? And then when we differentiate 3y, remember y now we treat as a constant. Okay, that's why we put red color to avoid error. Okay, so constant times 3 still equals to constant. And when we differentiate any constant, the answer equals to 0. Okay, and then minus differentiate constant 6, it is equals to 0 as well. Right? So this is our fx. Okay, then we simplify, so we have fx equals to 2x plus y plus 7. Right? Next, we want to find fy. Okay, to substitute into this formula. Okay, what is fy? Fy means partial derivative of f. Okay, we treat y as a variable. Okay, I use green color for variable y and I use red color for constant x. Okay, alright, when we differentiate x squared, now we treat x as a constant. So constant squared equals to constant. And when we differentiate any constant, the answer equals to 0. Okay? And then when we differentiate xy, okay? Right, to avoid error, we can write variable at the back, okay? xy. Okay, this one we write yx because here we treat x as a variable. Okay? Alright, so from here, you just imagine, let's say you want to differentiate 2y with respect to y. The answer equals to 2. Why 2? Because we just put constant 2 in front and then we differentiate y with respect to y equals to 1. But now, it is not equals to 2, but it is equals to constant x. Okay, but we use the same technique. Okay, we just put x in front. Okay, x means constant. And then we differentiate y with respect to y equals to 1. Right? And then minus differentiate y squared with respect to y equals to 2y. Alright? And then we differentiate 7x. Remember, now we want to find fy, means that we treat x as a constant. That's why we use red color to avoid error. Okay, so constant times constant equals to constant. And when we differentiate any constant, the answer equals to 0. Okay, and then minus, we differentiate 3y, it is equals to 3. Or, we just put back constant 3 in front, and then we differentiate y with respect to y equals to 1. Okay, and lastly, when we differentiate constant 26, it is equals to 0. Right? We differentiate one by one. Right? And then from here, we can simplify, so we can write fy equals to x minus 2y minus 3. Right? At this point, we done find the first derivative, the first partial derivative. Okay? Alright, after that, we need to find the values of fx and fy at the given point. Okay, so at point 3, negative 2, we find the value of fx. Okay, so we substitute 3 into variable x here, and we substitute negative 2 into variable y here. Okay, so after we simplify, we get fx equals to negative 3. Okay, and after that, we also need to find the value of fy at the given point. Okay, so at point 3, negative 2, fy equals to, we replace 3 into variable x, and then minus 2, we replace negative 2 into y here. Okay, and then minus 3. After we simplify this, we get 4y equals to negative 4. Right? Next, we recall back. Okay, to find the equation of tangent line, okay, first we need to find the gradient or the slope, okay, which is dy over dx. Okay, at this point, we done find the value of fx and fy, okay, at the given point. Okay, so next we need to find gradient, okay, or the symbol is m. Okay, gradient equals to negative fx over fy. Okay, equals to negative. We replace fx equals to negative 3. And then over, we replace fy equals to negative 4. Okay, negative times negative equals to positive 3 over negative 4. Or we can write negative 3 over 4. This is our gradient or slope. Okay, after we find the gradient, so we can use the equation of tangent line using straight line equation, okay, which is y equals to mx plus c. Okay, we replace our m equals to negative 3 over 4. We substitute here. So we get y equals to negative 3 over 4x plus c. Okay, now we want to find the equation of tangent line at the point 3, negative 2. So means that we need to substitute negative 2 into variable y. Okay, because negative 2 is the value of coordinate y. And we substitute 3 into x, because 3 means the value of coordinate x. Okay, so after that, we can solve for c. Okay, we have c equals to, after we solve this, c equals to 1 over 4. Okay, after we find c, then we can write the equation of tangent line at the point 3, negative 2 equals to, okay, y equals to negative 3 over 4x, and then we replace c equals to 1 over 4. So this is the equation of tangent line at the point 3, negative 2. Okay, equation y equals to negative 3 over 4x plus 1 over 4. Right? Got it? So this is the final answer, okay, for this question. Right? Equation of tangent line to the curve, this curve, okay, at the point 3, negative 2. Right? Madam, boleh kita rehat sebentar? Baiklah anak-anak, kita take file dulu, kita sambung lepas ni ya. Coming up next, sample of final exam paper MAT235 Calculus 2 for Engineers, ODL. You can subscribe, like, and share to support this channel. Thank you for watching. Stay tuned. Bye. Assalamualaikum.